So this test statistic gives us, we all work it all out, is 6.04. So just to point out here, if the observed and the expected values are very far away from each other, it makes each of these terms larger, right? Which results in the test statistic being quite large, and then having a small p-value and rejecting and saying that there is an association. If these numbers are quite close together, right? If the observed is very close to what we'd expect if they truly were independent, then each of these values will end up being quite small, in which case this will be a smaller test statistic and we'll have a larger p-value, which means that we won't have enough evidence for the alternative and we'll stick with the no. Okay. This test statistic follows a chi-square distribution, right? So remember, chi-squared is unimodal and right skew, something like this. The 6.04 falls on there. Chi-squared is defined by the degrees of freedom, and for types of tests like this, we always do the number of rows minus 1 times the number of columns minus 1. So in this case, we have 1 times 1, which is 1. So this follows the chi-square distribution with 1 degree of freedom. So that's what I'm going to draw here. And then my p-value is always the area to the right of that value. If you want to work that out, we have some nice R code. It's P chi-square, right? And you plug in your test statistic, your degrees of freedom, and then we always need to say lower dot tail is equal to false. Okay. So in this case, it will by default give you this area over here to the left. And so we need to tell it, no, we want the area to the right. Now, if you plug that into R, you will get 0.014 approximately. Okay. And so we'll take that p-value, the 0.014, and compare it to our alpha, which in this case was fixed to being 0.05. And obviously our p-value is smaller, okay, which means that we are going to reject H0. We have significant evidence here for the alternative. So let me just write that in words. We have significant evidence to suggest there is an association between cancer type and cell phone ownership. One thing I want to touch on specifically is that, yes, there is absolutely an association or a correlation between these two variables. Association or correlation does not mean causation. It might, but it doesn't necessarily mean that. So that does not mean, we cannot say here that cell phone use causes brain cancer. And the reason for that is there's lots of other variables that could be sort of associated with each of these variables that we haven't necessarily studied. So in order to get at causation, statisticians have a very specific process for that, the types of ways that you need to gather the data, the number of studies that you need to do. It's all very sort of determined if you want to get at causation, which is not what we have here. And so let me just give you a for instance that might help convince you why. So one variable that isn't considered here is age. Okay, and I would guess that age is associated with both of these variables. So for instance, let's think about people who are over 80 years old. They probably more likely are going to fall into the no, they don't own a cell phone, compared to those younger people, which, probabilistically, yes, they do own a cell phone. Not to say there's not some very tech-savvy 80-year-olds out there who own cell phones. I'm sure there are. But if we were talking about probability or likelihood, I think that age would certainly be an associated factor with both of those, whether or not you own a cell phone or not. And age might also be associated with whether or not someone has brain cancer. So, for example, older people tend to get different types of cancers. So, prostate cancer, skin cancer, other types of cancers are more likely among older people. Brain cancer tends to strike younger people. You don't tend to hear a lot of 80-year-olds getting brain cancer. So if you have a lot of young people saying, yes, they have brain cancer, and yes, they own a cell phone, and you have a lot of elderly people who are saying, no, they don't have brain cancer, they have a different kind of cancer, and no, they don't own a cell phone, that's automatically going to sort of create that relationship there, where there is a relationship between cell phone use and brain, the type of cancer that you have, when in fact it really might not have to do with the cell phone use at all. It might have to do with this confounding variable age. So again, we can say there is an association or a correlation between the two variables, but we're going to really, really avoid the use of the word causation.